Hello, my name is Aki. In this video, I want to talk about an interesting problem I found while working on a real-time strategy game. In real-time strategy RTS games, players often control many units at the same time. Moving a single unit is simple, but moving a large group smoothly and efficiently can be challenging. For example, if the movement system is not well designed, units may collide, get stuck, or move in an unnatural way. This becomes even more difficult when obstacles, such as walls or buildings, are placed on the map. To understand this issue better, let's take a look at how pathfinding is usually handled. When I was developing my RTS project, I used A-star pathfinding. A-star works very well for a single unit because it finds the shortest path from a start point to a goal point. However, when many units calculate their own path separately, performance becomes a concern. In addition, units may overlap or block each other, which creates unnatural movement. Because of these limitations, I started exploring other approaches that could better support group movement. During my research, I came across MAF, which stands for Multi-Agent Pathfinding. MAF is specifically designed to coordinate multiple agents at the same time. Although it can solve complex coordination problems, it felt more complicated than what I needed for my project. At this point, I shifted my focus from complex path coordination to a movement style and behavior. Since I wanted a swarm-like movement similar to games like StarCraft, I began looking into Boids. Boids is an algorithm that simulates flocking behavior, like birds flying together. What makes it interesting is that complex group movement can emerge from very simple rules. Boids is based on three main rules: separation, alignment, and cohesion. First, separation prevents units from getting too close to each other. Each unit checks nearby units within a certain radius. If another unit is too close, it moves slightly away. This creates a small pushing force that prevents overlapping and collisions. Next, alignment allows units to match their direction and speed with nearby units. Each unit calculates the average direction of its neighbors and adjusts its movement slightly. This makes the group move in a consistent direction and feel like one army instead of separate individuals. Finally, cohesion keeps the group together. Each unit moves slightly toward the average position of nearby units. This prevents units from drifting too far away and breaking the formation. When these three rules work together, they create smooth, natural swarm movement. Units avoid collisions, move in the same direction, and stay together as a group. With this understanding, instead of choosing between A-star and Boids, we can combine them. A-star can handle global pathfinding by calculating the overall route from the start to the destination. Then Boids can manage local movement, such as avoiding nearby units and maintaining swarm formation. Together, they create natural and coordinated group movement. However, even with this combination, another challenge appears when obstacles are involved. A-star often generate paths that pass very close to walls or sharp corners. For a single unit, this is usually acceptable, but for a large swarm, this causes problems. Some units may collide with the wall, cut through corner, or get stuck because the path is too narrow for the entire group. To address this issue, we need to consider the size of the swarm during the path calculation. One effective solution is to add a penalty value to nodes that are close to obstacles. In other words, nodes nearby walls have a higher cost. As a result, A-star will prefer paths that stay slightly further away from obstacles. This creates wider and safer routes that better fit the entire group. Because of this adjustment, the swarm naturally avoids sharp corners and moves more smoothly around obstacles instead of squeezing through tight spaces. To further improve the result, we can also apply path smoothing. After A-star generates the path, we can use a curvature or smoothing function to reduce sharp turns and create a more natural curve. This helps the swarm move in a fluid and realistic way instead of making sudden direction change. In summary, by combining A-star for global direction, Boids for local swarm behavior, obstacle penalties for safer routing, and path smoothing for visual smoothness, we can achieve efficient and natural group movement in RTS games. This approach allows large groups of units to move like coordinated swarm, while still avoiding obstacles and maintaining good performance. Thank you for watching. If you find the video helpful, please give us a thumbs up. If you would like to support the channel, you can find the links in the description below, and I will see you in the next video. Bye bye.